Hey guys, welcome to your flip video on water quality. This will be page 32 in your notebook, so if you want to go ahead and turn to page 32, you're actually going to be drawing sort of a note-taking template in order to get through these flip videos. Okay, your note-taking template might look something like this, where you have an introduction section at the top where you'll take some introductory notes just on what water quality is, and then you'll divide it into having temperature, pH, turbidity, dissolved gases, salinity, and then a section for aquifers. You are not required to make a data table like this. You can do your notes any way you want. I just thought this might be an idea to keep your notes organized. So we're going to start with just an introduction on what water quality is. All right, so first of all, water quality is basically how good is the water, how clean, clear, salt-free, or low salt is it? And we really want our freshwater supplies to have good water quality for our purposes. And of course, we also want our ocean supplies to have good water quality. Water quality is usually tested in local areas every week, if not more frequently, and then also every month. Okay, so when we talk about water quality, we're going to focus on a few characteristics. Temperature is one, pH, which stands for percent hydrogen, turbidity, dissolved gases, and then salinity. And I'm going to go through each one of those and give you a more in-depth description of what that is. Okay, so the quality of water stays pretty consistent in our marine ecosystems. Oceans and freshwater, Mother Nature does a great job of keeping those balanced. But sometimes there can be sudden changes in those water supplies. And when that happens, and I apologize, let me move myself up there. That might help you. Okay. For marine organisms, when there are sudden changes, those can become life-threatening and wreak havoc on the ecosystem. So let's first start talking about temperature. Hopefully you know what temperature is. All right, shallow water tends to be warmer, all right, than deeper water because sunlight can penetrate shallow water from top to bottom a little easier, which tends to make it warmer. Deeper water is going to be cooler, all right, which means it will have less dissolved gases in it. Warmer water, the molecules are moving pretty rapidly, which means the water has a hard time adhering to anything else like extra oxygen or things like that. So there will be less dissolved gases in shallow water. In deeper water, because it is cooler, you will get more dissolved gases, and I'll talk about that when we get to that slide. All right, water can undergo something called thermal pollution. This is typically caused by factories. Factories, even here in the Raleigh area, are going to use water as a natural coolant for things in their system. And because they're using that water and recycling it, the water comes back into the water supply warmer, all right, which is thermal pollution, which could be detrimental if the water temperature gets too high. Sometimes you get runoff off of hot asphalt, roads, streets, sidewalks, things like that. And this will cause the water to increase in temperature. And we don't want water to be outside of its normal temperature range. When the water does get warmer because of some of these thermal pollution sites, it increases the rate of photosynthesis. And that will create algae to bloom on the surface of those waters. And you think, well, we're increasing the rate of photosynthesis. That's a good thing. And it is to a point. But if the entire pond gets covered with these algae blooms, sunlight cannot penetrate, all right, deep into the water, which means photosynthesis at those deeper depths will be greatly or dramatically decreased, which will wreak havoc on those marine animals living down there and plants. If plants can't get the sunlight they need, they can't undergo photosynthesis, which means the amount of oxygen available for the living animals in that ecosystem is going to be greatly diminished. So it's really a good balance. It's a delicate balance of temperature when we talk about our water supply. All right, pH is percent hydrogen. All right, when water mixes with certain substances, it can get broken down into hydrogen and hydroxide. So water is H2O, and you can see hydrogen is a positive. All right, hydroxide is a negative. All right, ions basically means a molecule that has a charge to it, negative or positive. So water can become acidic or basic, and so we're going to talk about that scale and what acidic versus basic means. So the pH scale is a range of pH levels from 1 to 14. All right, if you are a pH of 1 to 6, you are considered acidic. 7 is something called neutral, which we want water to be neutral. We don't want it to be too acidic or too basic. Or you're on a scale from 8 to 14, which are basic. What makes them acidic or basic? If you are acidic, you have more hydrogen ions attached to the water, and if you're basic, you have more hydroxide ions attached to the water, which can be a bad thing. Things that are acidic are like lemon juice, hydrochloric acid, those sort of things. Things that are basic would be something like the cleaning agent ammonia. All right, and when you are not at a neutral 7, organisms in the water can't function like they're supposed to because of those acid or basic levels. So turbidity, dissolved gases, and salinity, we're going to talk about those 3 on this one slide. Turbidity is basically how cloudy is the water, all right, how clear is it, and I'm going to talk about that little black and white disc here in a minute. When they test fresh water or salt water for turbidity, it's tested using a Secchi scale, and it's basically a disc that is a checkerboard pattern of black and white sections, and it has a rope attached to it that will have knots every few meters, and they lower that disc into a body of water, and they lower it knot by knot until it reaches a point where they can't tell the difference between the black and white sections of those discs. The deeper it goes before the colors become the same, all right, the more clear the water is, which means it has less turbidity. So the waters of the Caribbean Ocean or the Caribbean Sea are going to be less turbidity than Falls Lake, because you can lower that disc pretty far into the nice clear waters of the Caribbean than you can with Falls Lake. Dissolved gases are basically what they say they are. It's the amount of oxygen and or carbon dioxide dissolved in the water supply. More dissolved gases like oxygen are found in cold, deeper water because the molecules of those water, the things that are colder, are closer together, which means they have a greater chance of trapping some of those gases. Salinity means how salty is the water, and there's a range of salinity when we talk about the water supply here on Earth. So fresh water is going to have little to no salinity, which is what we want if that's what we're using for our daily lives and living. Brackish is going to be where salt water meets fresh water. So if we think about the Neuse River Basin and all the fresh water from Wake County heading towards the beach empties into the Pamlico Sound, which is salt water. All right, where those two meet, you have brackish water. So higher salinity than fresh water, but less than the ocean. Salt water is going to be found in our oceans and some other possible lakes and ponds, but not here in Raleigh, North Carolina. And then there are some bodies of water that are called hypersaline, like the Dead Sea is hypersaline. It has so much salt content in it that little to no marine life is going to live there. So when we talk about salt water and fresh water, we really have to focus on the storage system of fresh water and how we make sure we're monitoring the quality of that fresh water for our consumption and use here on planet Earth. So an aquifer is basically a storage basin of fresh water. It's an underground layer of permeable, which means water can move through it, material. Gravel, silt, sand are great materials. Things that would be impermeable would be bedrock, right, large chunks of rock that have no space between them. And this is where groundwater gets stored. It gets stored in something called an aquifer. In an aquifer, we have to monitor the water table. So the water table is how high does that groundwater level get. All right, it's really important to know where the water table is, because if you're going to drill a well, you have to make sure that it is well below the water table to have a nice steady supply of fresh water. So I'm going to show you a picture of an aquifer. I'm not saying you have to draw it. It's totally your choice if you feel it's necessary. So here's a typical aquifer. All right, you can see our water table here in this case is pretty high. It's this line or section right here at the top. We do have some surface water here, which could be a river, stream, pond, lake, anything. But down here, this water will seep down into the soil, sand, gravel, whatever might be underneath of it. You have a section of groundwater here, which is water that basically seeps below the surface after it rains or is seeping through the bottom of a surface water collection area. You have something called this confining layer, and what it is, it's still permeable material. It's just a little more compact, which actually acts as a filtering system to get water down into the aquifer. And when it puts water down here in this large collection area, it's actually quite clean after being filtered through this confining layer. So if you think about a droplet of water or a a puddle of water that seeps down into the ground, it gets one section of filter and ends up as groundwater. It seeps through this confining layer, gets a second filtration. So we're talking about pretty clean, good quality water here in the aquifer. So a well, if anyone who lives in a well community or uses well water for their water source, you have to dig that well deep. You have to hit the aquifer because this is going to be where we store that underground water. And you notice this well is very deep, well below the groundwater, well below the water table into the aquifer, and they will pump water up for use in their home, farm, or wherever that well may be. And monitoring the quality of our aquifer using temperature, pH, turbidity really helps us use that fresh water, clean fresh water here on the surface of Earth.